Now let's take a look at some of the details in SPC. And one of the first things we're going to talk about is variation. So basically, no two things are exactly alike. So if we had a part, let's say it was a piece of metal, and it had a hole in the center, and we wanted to take a look at, we could take a look at a number of things in this, but let's just, for our discussion, take a look at the diameter here. And let's say that is supposed to be exactly a 1/4 inch. So as the parts are coming down the line, we're going to measure the diameter. And let's say, we're getting measurements like 0.25, 0.24, 0.23, 0.26, and so on. Now, when we take a look at those over time, we start seeing a pattern develop. So we want 0.25, and let's say it goes 0.26, 0.27, this way 0.24, 0.23. So this is our diameter on this axis. And then we have another axis here, which is our count. How many parts actually have that particular measurement? So if we have one that's 0.25, we're going to increase this count. And if we have one that's 0.23, we increase the count over here. This is also called, commonly called frequency. Okay. So we take our first part and we measure it, 0.25. Next one, 0.24. And 0.23 and a 0.26, and we keep measuring these parts, and each time that part has that measurement, we're going to tally, and we're going to form a pattern here. And this pattern is, for a healthy process that's normal, is going to just generate a real nice, what we call, bell curve. So it starts out down here, and it forms a curve like this. And that's what we call a normal distribution. In other words, this is a normal distribution of our measurement values and how they're going to vary on a normal process. Now let's take a look at a process that's maybe not normal. So we'll put our same chart down here. And this is our diameter, and this is our frequency. And we start plotting our points. But instead of them being aligned on the 0.25 there, we're finding that it's more like this. It's all shifted over into the 0.26. So maybe we have machine wear over time, and we're starting to have a trend where everything's shifting to the right. So our ideal standard or normal distribution is up here. Our actual is shifted over. Our actual bell curve is over here. Now we see we have a shift in the peaks of our bell curve. That's just one example, but this bell curve can flatten out. We can also see all kinds of other odd-shaped bell curves that indicate that we're starting to have a problem from with our quality. We're not fitting that normal distribution. Also on this bell curve, we can have limits. So if we have right here, we have maybe at 0.229 and up here at 0.275 or something like that, are spec limits of if a part falls out of that, then it's just obviously way out of control and we need to do something about it or not accept that part and not include it in our production. So as this is shifting, we have a part go out of that spec limit and we're further away from this spec limit. So it can be a problem when this shifts or flattens out. So we're looking at measuring the variation of parts. We need to be able to measure it. All parts are not going to be exactly the same. We start tracking it and we see a pattern form. And in a healthy pattern, we see our normal distribution. And in something that is not good quality, something going wrong, we start seeing a change in it. And we want to detect that change and fix that as soon as possible. So that's the first item of SPC, is the variation.